या इधर और यहाँ पे हमने चीज़ समझनी है कि समरी में क्या है, इंटेलिजेंस रिक्वायर्ड होगी, ए आई नीडेड, इफ़ एंड एल्स अलोन, नो ए आई नीडेड। ओके, ये चीज़ दिस वन, डेटा needed, data needed for pattern to recognize data available, to recognize pattern is to ML needed, or otherwise if there is no data such as okay, predefined if else rules, ML not needed. So so yep, data availability to run patterns, data type, define data type, unstructured data, deep learning needed, structured data, audio, video, okay, structured data, spreadsheet, not needed. So that's what it is. Let me ask this summary from chat. Is this right and understanding? And here it also says if and else plus a, only if else, no AI. It has okay, so the transformer model generates a response that is deep learning. If response contains harmful content, refuse and replace it. This is the if else safety filter. So the real question, does the system have if else? The real question is, does the system also learn from data, or is it only if else? Okay, so this is what we your framework is mostly write a few lines, small fixes is word, intelligent required and needed, if else alone, no AI, predefined rules, ML needed, correct, unstructured data, correctness is correct in practice, structured data, correct, deep learning not needed, data available, ML needed. This is the available equals ML needed. Partially right. Data available means is an option, not the only option. There are other ways AI learns that also touch data differently. The big gap, other ways AI learns. ML is just one of the four main learning approaches. Here's the full picture. Supervised learning needs label data. Someone shows the AI thousands of examples with correct answers. This email equals to spam. This email not spam. Model learns the pattern. Most common ML, fraud detection, this thing, image classification, this thing. Unsupervised learning reads data, no labels in it. You give the AI raw data with no answers. It finds the groupings itself. Itself. This is not the labeled data. Here are 1 million customers. Figure out how they cluster. Nobody told it what to look for. Customer segmentation, anomaly detection, topic clustering. This is how the clustering works. Okay, got it. This is the categorization, labeled one. This is the unsupervised learning, which is doing the clustering with respect to the patterns. Now I'm getting the sense. Reinforcement learning. No pre-existing data generates its own. No data set. The AI learns by doing, takes action, gets rewarded or penalized, adjusts. Like training a dog. No textbook, just good move, treat, bad move, no treat. AlphaGo beating world class chess champions. Self-driving car, steering game playing AI. Transfer learning needs very little new data. Take an AI already trained on millions of examples. Transfer learning needs very little new data. Take an AI already trained on millions of examples, teach it something new with just a few hundred. Like a doctor who already knows biology, learning a new specialized field takes weeks, not years. Fine tuning ChatGPT for your company, medical imaging on a small hospital data set. Got it. Okay. Your framework, intelligence required. Can rules be only explicitly? Explicitly, yes. If I know I need it, no. This one is there interaction, trial and error possible. Reinforcement learning, no. Need data, what kind? Labeled, unstructured data, no data set need. Reinforcement लर्निंग में ये होता है कि AI learns by doing, takes action. ओके नो ये खुद से ही जो है ना वो कोई चीज़ करती है, फिर वहाँ से वो जब वो कोई चीज़ कर रही होती है तो उसमें जो डेटा जनरेट कर रही होती है वो तो इसमें ये होता है कि अच्छा जी यहाँ पे ओके यहाँ पे एक चीज़ होती है कि रीइंफोर्समेंट लर्निंग होती है, तो जो आपका डेटा होता है नो डेटा सेट नीडेड. रीइंफोर्समेंट लर्निंग नीड डेटा, तो यहाँ पे इज देयर इंटरेक्शन, ट्रायल एंड एरर पॉसिबल. रीइंफोर्समेंट लर्निंग में आपको नहीं होती भी, वो खुद अपना डेटा जनरेट करता है. ठीक है, इसमें आप लेबल वाला डेटा देते हो, इसमें आप बगैर लेबल का डेटा देते हो, इसमें आप उसको कोई डेटा नहीं देते. और एआई जो है लर्न्स बाय डूइंग होता है, रीइंफोर्समेंट लर्निंग होता है, टेक्स एक्शंस, गेट्स रिवॉर्डेड और पेनलाइज एडजस्ट. Like training a dog, we also get trained with this thing, alpha reinforcement learning. Okay, just good move, treat, bad move, no treat. So that's how it's a reinforcement learning. Transfer learning, take an AI already trained on millions of data, needs very little new data. तो इसमें ट्रांसफर लर्निंग, इसमें तो आपकी नीड्स लेबल डाटा ही होता है. इसमें आप बताते हो कि लर्निंग अ न्यू स्पेशलिस्ट फील्ड टेक्स फ्यू ईयर्स. सो इसमें डेटा नहीं रिक्वायर्ड होता है. और ML is just one of the 4 approaches. Here is the full picture. Okay, are these these 4 approaches comes under ML? Okay, I'm getting it here and there. So लेबल डेटा अगर है तो सुपरवाइज ML unsupervised ML. Transfer learning, very little data, no existing. Data type structure, regular ML. Uh, Images, deep learning. Data type, is there interaction trial and error possible? Can rules be written explicitly? So transfer learning, take an AI already trained on millions of examples, teach it something new with just a few hundred, like a doctor or this one. Yes, but one very nuance. Supervised and reinforcement learning are all types of ML. Classroom is slightly different. It is technique used inside those types, not a type on its own. Okay. Here is this a hierarchy. Machine learning, one way AI learns. Supervised learning, unsupervised learning, learns from labeled data. Emails, memorized time, finds patterns in unlabeled data. Here are 10 10,000 customers. Figure out the groups yourself. Reinforcement learning learns from rewards, penalties. No data set. Try, fail, adjust, try again. Learns from rewards and penalties. No data set. Try, fail, adjust, try again. Reinforcement learning, it means that learns from rewards and penalties. No data set. Try, fail. So yep. A deep learning, a tool inside ML, uses neural networks applied to any of the above. Supervised DL, yes, DL, AlphaGo, Deep, RL. Okay. Transfer learning sits across all of these techniques. Transfer learning take any trained ML model, adapt it to new tasks with very little new data, not a type of learning, a shortcut inside existing types. So approve supervised learning, type needs data, yes, labeled, so this is under ML. Unsupervised learning, type yes, unlabeled, this come in C ML. Reinforcement learning, type no data set, learns from interaction, yes, under ML. Deep learning, tool subset, yes, large large amounts, yes, tool subset. Reinforcement learning, no data set, learns from interaction. hmm, Reinforcement learning, rewards or penalties. Transfer learning technique है, very little applied within others. So एक ट्रेन ML मॉडल जो कि इन तरीक़ों से ट्रेन हुआ हो, सुपरवाइज लर्निंग और सब लर्निंग से, और उसको कोई हम कुछ नया हम उसको दें और वो उस पर उसको लर्न कर ले, तो ये है supervised. Teacher shows right answer, student learns. Unsupervised, no teacher, student finds patterns alone. Reinforcement, no teacher, no data, student learns by doing and failing. Deep learning, the most powerful student needs the most examples but handles the hardest problem. A student already trained in one subject picks up the next one fast. Oh, it is getting interesting. Man. Yep, you can see it is getting interesting now. So one thing I have to see here. So here we have to go. Okay, now we have to give this thing. मैं यहाँ पे जो अनस्ट्रक्चर्ड डेटा, अगर अनस्ट्रक्चर्ड डेटा है तो वहाँ पे डीप लर्निंग की ज़रूरत है, वरना नहीं है. तो यहाँ पे इसने मुझे बताया कि ये ML की ये टाइप्स हैं और लर्निंग वेज हैं. So there are 5 machine learning ways. Four main learning approaches. Finite rules supervised comes under this one. Unsupervised reinforcement learning, transfer learning technique, and deep learning. Let's see what it tells to us, what exactly it means. Not exactly, not exactly. They belong different categories. Here is the honest. Supervised learning learns from data. Unsupervised learning finds patterns in unlabeled data. Reinforcement learns from rewards and penalties. Uh, these are two types of ML. Everything else sit on top or inside these. Deep learning and transfer learning are different in nature. Deep learning are tool, a powerful neural network architecture applied inside supervised, unsupervised, and reinforcement, not a separate type. Okay, transfer a technique. Reuse an already trained model. Okay, applied inside any of the three, not a separate type. The correct one: ML type 1, type 2, type 3. Can use deep learning as the tool. Can use transfer. Can use transfer learning as the shortcut. Can use deep learning as a tool. Can use transfer learning as the shortcut. Can use deep learning as a tool. Can deep reinforce called deep reinforcement learning. So tool, architecture, technique, shortcut, not a type, not a type. Okay, think of it like cooking. Supervised and 3 cooking methods. Boiling, a powerful oven. You can you can grill, boil, or bake inside it. Okay, in transfer learning, using yesterday's app work, not a cooking method, just a smartest way to do this thing. So we can use the deep learning in the transfer learning to gain new skill on extra data by already trained model. So let me clear this confusion as well. Hopefully it will be done. Okay. Okay, yes, exactly right. This combination is the most powerful things happening in AI. What you just described has a specific name, fine tuning. Okay, pre-trained deep learning model is plus a small amount of specific data. A model gains new skill without starting from scratch. How it actually works? Start with actually trained model, trained on massive data, already knows general patterns. GPT trained on billions of internet pages. Add your extra data, small, specific, targeted. Example: 100 medical reports from your hospital. Train again on new data. Models adjust its knowledge. Keeps general skills. Adds new specific skill. Keeps general skills. Add new specific skill. New capability unlocked. Now it understands medical language specifically. Real examples of this happening: pre-trained model, GPT, internet text, medical records, medical AI. Okay, this is the fine tuning. This is just the fine tuning. Image scan photos, already know how to scan. X-ray scans, cancer detection. New skill gain, मेडिकल रिकॉर्ड्स दिए, एक्सरे स्कैन्स दिए, उसको बोला कि कैंसर बताओ क्या खाओ, और इसमें हमने उसको डीप लर्निंग से करवा दिया. बर्ड, विकीपीडिया, लीगल डॉक्यूमेंट्स, लीगल डॉक्यूमेंट रीडर. GPT, internet text, your company data, your own company chatbot. Speech model, general audio, and general audio, and general Urdu voice data. We gave the Urdu voice data to her, and then what it does, speech model. Okay, speech model, उर्दू वॉइस डेटा. हमने स्पीच मॉडल है, जनरल ऑडियो है, इसमें रिकग्नाइज करता है वो. और ओके, स्पीच मॉडल, जनरल ऑडियो, उर्दू वॉइस. ओके, उर्दू वॉइस डेटा, उर्दू स्पीच रिकग्निशन. ठीक है, तो उर्दू वॉइस डेटा आपने दिया उसको, और उसने उर्दू स्पीच रिकग्निशन पढ़ लिया. ठीक है. वाई दिस मैटर्स द एफिशिएंसी. ट्रेनिंग फ्रॉम स्क्रैच नीड्स मिलियंस ऑफ एग्जाम्पल, नीड्स मंथ्स ऑफ कंप्यूट कॉल टाइम, कॉस्ट hundreds of thousands of dollars. Fine tuning a pre-trained model needs hundreds or thousands of examples, takes hours or days, cost a fraction. The analogy to complete the picture: a doctor graduates medical school after 6 years, and that is the pre-trained model, trained on massive general knowledge. A doctor graduates medical school after 6 years, a pre-trained model trained on a massive general knowledge. Now the hospital wants them to specialize in cardiology. They do not repeat 6 years of school, they do a 6-month fellowship using new specific data, heart cases only. The fellowship fine tuning, the new skill transfer learning via deep learning. Your updated understanding is now correct. Deep learning builds the powerful pre-trained model is massive data, massive compute. Transfer learning takes that model, add a small new specific, teaches it to new skill fast, needs little data and little compute. Fine tuning the actual process of doing this. Woohoo! Got it. Okay, 3 things, 1 pipeline. This is exactly should be modern AI works. Okay, got it. So my understanding is good. So this understanding I have to do. Explain it again. So let me see some few things. Good question. To revisit these two lines, code decision analyzing or not, this single question that decides everything, everything, everything. Okay, the single question that's defined that decides everything. Can a human expert write down all the rules needed to solve this? Yes, if else enough. Mm. No, no ML needed. Rules are too complex. ML needed. And can human expert write down all the rules needed to solve this? If else is enough. Predefined rules. ML not needed. There are problems where a human already knows the answer and can write it down explicitly. If a this one plus this one, nobody needs to learn these from data. A human already knows the rules. You just write it down once. The rule is known. The rule is clear. The rule does not change. If else, no ML. Data availability to reconcile ML needed. These are problems where the rules are too many, too unknown for any human to write down. Fraud detection. If transaction amount this in fraud, no. Majority people spend 100 $500. If transaction in foreign country, fraud, no. People travel. If transaction at 3 a.m. Fraud, no. People shop at night. The pattern are the pattern of real fraud is a combination of hundreds of signals. The pattern of real fraud is a combination of hundreds of signals. Impossible to write rules for all of them. Uh, the pattern of real fraud is a combination of hundreds of signals. Impossible to write rules for all. The pattern of real fraud is a the pattern of fraud of real fraud is a combination of hundreds of signals. Impossible to write rules for all of them. But you have data. 10 million past transactions labeled fraud. Okay, but you have data. 10 million past transaction labeled fraud, not fraud. Email finds the pattern you cannot write. Okay, yeah, spam detection is also there. Medical diagnosis. So let's complete the understanding. Can a human write the rules? If the ML contains lottery spam, a spammer is stopped using that word. If ML as we many swimmers stop using where rules break the moment swimmer adopt. You cannot keep writing new rules forever, but you have data, millions of images labeled spam, non-spam. ML learns what spam looks like even as it evolves. ML needed. Medical diagnosis. Can you write the rules if patient has fever and cough, flu? Could also be COVID, pneumonia, flu. No, maybe another thing. There are thousands of symptoms, hundreds of diseases, millions of combinations. No human can write rules for every possible combination, but you have data, patient records plus confirmed diagnosis. ML finds the pattern doctors could never manually code. ML needed. Okay, rules known. If else, yes. Too complex. ML too complex. Rules if else, rules known, too complex. Human can write, yes. Too many. ML rules stay the same, yes. If else, so rules stay the same. Human can write rules known. Okay, yeah, patterns change होता है यहाँ पे. Data needed if else. Now इससे काम चलेगा. इसमें चाहिए free shipping rule, fraud detection rule. So the simplest way to remember, if you can finish the sentence if equals to then, you do not need ML. Write the if else and move on. If you cannot finish the sentence because there are too many variables, too many combinations, and or the pattern is too complex to put into words, you need ML. Learn the data define the rule. Real world check. Word check. Before building any AI system, ask this first: can I write the rules myself on one page? If yes, save time, money, and complexity. Write the if else. If no, you have genuine ML problem. Now find the data. Oh yes, got it. So that's where we need data or not. Data needed. Predefined rules. So this thing I think so. So data type, structured data, spreadsheet, deep learning not required. So that's my analogy. Electric car, is data needed? Intel, I can do this. Okay, this is the one more thing. Here the if else is also some kind of intelligence, then how it is differentiating from the intelligence required. If else is a form of intelligence, human intelligence encoded into a system. Early AI and was entirely burned. If they are called expert system and were considered AI at the time. So the line needs to be drawn more carefully. The real distinction is not whether there is intelligence, it is where the intelligence comes from. If else system intelligence comes from the human who wrote the rules. The system just executes. The system itself is not thinking. The intelligence lives in the programmer. ML AI system intelligence is generated by the machine from patterns in data. The system discovers rules humans never wrote. The intelligence lives in the model. Okay, same outcome, completely different source. Fraud detection offense version. Okay, a human expert sat down, thought if this thing controls on it. Now the human was intelligent, the system was just followed the instruction, remove the human, no intelligence left. Fraud detection ML version. No human wrote those rules. The system looked at 10 million transactions, found patterns no human noticed, and built its own understanding of fraud. No human wrote those rules. The system looked at 10 million transaction, found patterns no human noticed, and built its own understanding fraud. उससे ये हुआ कि हमारे पास इतनी ज़्यादा ट्रांजेक्शन हुई कुछ लोगों की, फिर हमें जब वो फ्रॉड उसमें हो गया, फिर हमें इल्म हुआ अच्छा यार ये जो ट्रांजेक्शन जिस आदमी ने की थी यार ये तो फ्रॉड निकली। तो इस तरीके से बस हमने वो ट्रांजेक्शन की लेबलिंग कर दी कि इन दी एंड ये जो ट्रांजेक्शन थी ये भाई फ्रॉड हुई और ये फ्रॉड हुई नहीं। अब हमें ये नहीं मालूम कि वो कैसे फ्रॉड हो जाता है, बस हमें ये हुआ कि इन दी एंड जो है ये इसका नतीजा निकलता है ऐसी ट्रांजैक्शंस का। तो उन ट्रांजैक्शन में क्या पैटर्न होता है या क्या हमारे सिस्टम में लूप होल्स होते हैं जिनको बाईपास करके इन दी एंड वो फ्रॉड हो जाता है। तो वो जो पैटर्न्स को रिकग्निशन है वो हमें मशीन लर्निंग करके दे देगी। So build its own understanding of fraud, found patterns no human noticed, and builds its own understanding of fraud. No human wrote those rules. The system looked at 10 million transactions, found patterns no human noticed, and built its own understanding of fraud. The machine generated the intelligence, removed the human intelligence. It still exists inside the model. The analogy that separates them: a book is full human intelligence, but the book itself is not intelligent. Mm. It cannot answer what it was not written for. It cannot update when the world changes. It just stores what a human already knew. If else, a book. Human intelligence uh, is stored inside a system. Static fixed cannot grow. A student reads, can connects and discovers. They can answer questions never thought of. So they can answer questions never thought to them. They improve the more they experience. They improve the more they experience. They generate new understanding. ML, a student, machine intelligence generated from data. A student reads, connects, and discovers. They can answer questions never thought to them. They improve the more they experience, and they generate new understanding. Hmm. They generate new understanding. ML, a student reads, connects, and discovers. They can answer questions never thought to them. They improve the more they experience. They generate new understanding. ML, a student, machine intelligence generated from data, dynamic, adaptive grows with more data. Just I am doing it. So the correct version of your framework: before inference alone, no AI needed; incomplete after inference alone, no human intelligence encoded. Into a system executes, system does not learn, system cannot improve, no machine intelligence generated. Not what we mean by AI today. In expert system, sophisticated inference rules, and machine learning patterns learn from data. Machine learning patterns learn from data. Deep learning and neural network on massive data. The definition of AI kept moving forward as machines got more capable. If as expert systems were the AI at their time, today when we say AI, we mean a system that generates its own intelligence from data, not one that executes human written rules. Today, when we say AI, uh, we mean a system that generates its own intelligence from data, not one that executes human written rules. The one liners are separated from: if you remove every human who build this system, does the intelligence disappear or does it stay inside the machine? If also intelligence disappears, it was always the humans. ML, DL, intelligence stays, machine generated it from data, it belongs to the model. Now, okay. So, तो हमने इफ एंड एल्स जो इंटेलिजेंस आई वो इंसान से आई, सिस्टम ने सिर्फ उसको एग्जीक्यूट किया। और जो इंटेलिजेंस आई मशीन लर्निंग में, एआई में, वो उस डेटा से आई। उसने खुद ही उस पैटर्न को रिकॉग्नाइज किया उसमें से, और फिर अगर उसके पास कोई नई चीज़ आती है कि यार इसमें ये पैटर्न रिकॉग्नाइज करके दो, तो वो उधर से रिकॉग्नाइज करके दे देता है। तो यानी कि उसने जो इंटेलिजेंस जनरेट की, उसने डेटा से, जो उसके पास डेटा आया उससे उसने सीख के इंटेलिजेंस को अपनी बनाए, अपने रूल्स बनाए उसको समझने के बाद. सो दैट्स व्हाट इट इज. सो ओरिजिनेशन ऑफ इंटेलिजेंस, गेट इट. तो कहाँ से वो इंटेलिजेंस ओरिजिनेट हुई है, तो ये है. सो आई गॉट इट. सो आई थिंक सो intelligence needed, so data needed, so AI ML method tool. So this is machine learning, ML, deep learning, AI, AI. So this is now us. Is AI needed? Are we trying to make something behave intelligent, or just the automated? Something to generate its own intelligence. So let me clarify this thing as well here. This is actually better than the most definition. Here is working perfectly. So it ties everything before the intelligence required, AI needed. To wake in after generate its own intelligence, AI needed. Precise is actually that separates AI from everything. Now you have the full framework, the AI from machine explicitly. Predefined if else. You have right now something to generate the intelligence AI needed. Okay, data available to recognize the payment. Predefined rules cover the problem. Unstructured data, deep learning, structured data, spreadsheet, deep learning model or retrain plus small new specific data. fine tuning, we are transfer learning. So that's the thing I am doing here. Specific data, predefined rules already. Uh, rules. Okay, so let me see that. If is this one, and every AI type is perfect under this one line generate its own intelligence from label data. All five generate their own intelligence, different methods, same the complete framework. If and also or this one, everything above the movement you need machine to expected told it. The AI begins. Correct. The word predefined is doing important work here. Okay, predefined if and rule a human sat down and wrote it down. The rule exists before the system. So yeah, predefined rules. So predefined. So yep. AI needed. Okay. So we get the two line. Your two lines now capture parameter something generates on your head predefined as a rule alone. Is alone, and this thing is in predefined rules versus emergent. That's the real line. Your framework is not precise, it's incomplete. Emergent, intelligent. So yep. Yo, so I have to do this thing. ओके गाइस, जब तक ये हो रहा है मैं इसको देख लूँ पहले ना. ये क्या इसने बताया कि जनरेट प्री डिफाइंड मीन्स अब ह्यूमन written down the rules. If x happens do y. The rule existed before the system ever saw a single real example. Human decided, machine just follows. AI generates its own intelligence. No human pre-wrote the answer. The machine looked at the data and discovered the pattern itself. The rule was found after seeing evidence. Data decided, machine discovered. The timeline is what separates them. If else, rule written, then data arrives. Human first, data second. Data arrives, then rules discovered. Data first, machine second. Your tool are now capture something that is so intelligence AI needed. Machine discovers the rule from data did not exist before the data. Predefined if else rule alone. No AI needed. Human wrote the rule. Human wrote the rule before the data existed. Before any example. Oh my god. Before emergent. Human wrote the rule before the data existed, before any example was seen. Okay. Okay, one word, prescribed intelligence, rules handed down by a human. Emergent intelligence, rules emerge from the data. Predefined rules, emergent. Your framework is strong, mostly correct, but into improvement, something that's or intelligent is right, unexpected data in this. This implement 2. Your version, the ML, if AI needed, ML needed. Data to recognize better, ML needed. Predefined issue, ML not needed. At level 2, you already decided AI is needed. Predefined if AI rules rule out repeating it here creates confusion. Also missing what if AI is needed, but no pre-existing data exists. That is reinforcement learning. Your framework currently has no place for it. The improved framework is got it something to generate its own intelligence. Correct predefined rules alone. No stop here. No did it. Okay, great. Data exists or recognize patterns. Yes. ML needed. Go to level 3. No. Reinforcement learning learns by doing. Learns by doing. Hmm. Learns by doing. No pre-existing data needed. AlphaGo robotic self-driving car steering. Which type of ML data is labeled? Hmm. So reinforcement learning learns by doing. No pre-existing data needed. AlphaGo supervised learning. Okay, data is unlabeled. Unsupervised learning. Deep learning needed. Unstructured data. Structured data. Okay, unstructured data. Deep learning is not needed. Regular ML is enough. This one. Transfer learning possible. This 5. So the one condition fixes everything. Before your framework said AI needed only 2 data equals to ML if it's on the wrong level. Now the framework says AI needed 3 data exists, ML learning no data existing model. Okay, okay. Uh, is the reinforcement learning coming under the ML? Okay, okay. Think so. Okay, so here we go. Yes, reinforcement learning is under ML, and this creates a small inconsistency in the framework we built together. Let me get honest. अगर डेटा होगा तो ये वाला आ जाएगा, अगर डेटा नहीं होगा तो ये वाला आ जाएगा. All three are official types. Why inference supervisor need pre-existing data, needs same family different data source, needs no pre-existing data, generate its own data through interaction and experience. Reinforcement learning, that difference made it feel separate, but it is still ML the consistent craze. Data exists, no data. Reinforcement learning. This is the wrong because reinforcement learning is ML. It should be inside. The correct version is. So I think so. So I think so. This one is right. Seems this one is right, as it is not saying that the data to be given already or to be generated on its own. Okay, so the reinforcement learning here, you can see that yes, this creates a small inconsistency. Why it felt separate? Their reinforcement, the learning, right? The correct framework, we can say you're correct. अगर डेटा नहीं तो अपना खुद बना लेगा, डेटा कलेक्ट करेगा, फिर उसके बाद उसमें लेबल करेगा, अच्छा ये चीज़ मुझे हासिल हुई, ये चीज़ नहीं हासिल हुई, एंड देन इट इज़ keep restoring. It should sit inside ML, not outside it. The corrected framework generate its own intelligence. All options here are pre-existing labeled data, unlabeled data, no pre-existing data, reinforcement learning. Deep learning, and is this one transfer learning. Pre-trained exists, pre-trained model exists, small new specific data, fine-tune, do not train from scratch. Okay, no pre-trained model trained from scratch. The corrected one-line summary, data, no data, first learning, wrong. All three, when the reference only data source, supervise and generates its own through interaction. One analogy, a student can learn three ways. All three are skill called read a textbook with answer, a raw research paper, find patterns alone. Unsupervised learning, learn by doing, following and adjusting. Reinforcement learning, three methods, one category learning, same in ML. You're absolutely right. Your original line was correct. I over corrected. AI को भी कंफ्यूज कर दिया भाई हमने तो. Here is why your version is actually more accurate. Data needed to recognize pattern and rules. ML needed. It does not say data is pre-existing label or must be collected by someone. It says the data is needed, and it covers all three types of perfectly. Needs data, pre-existing labels, needs data, pre-existing unlabeled data. Reinforcement learning needs data, generate its own through interaction, but it still needs data to learn on three data needed. If else we define rules, no data needed. Humans write the rules from their own head. So yeah, the elegant truth, your line captured the difference between if is not where the data comes from. It is whether data is involved at all. ML always needs data source, does not matter. If else never needs data. Human rights rules correct directly. Your framework level 2 confirmed correct. You recognize pattern and rules defined as rules or instinct was sharper. Oh, oh, I got a compliment from AI. Oh wow. Okay, guys, it's nice. So, yep, I think so. ML needed, deep learning needed. Okay, what what are other rules? Or other rules? Other ways other than ML AI used to learn? So I think so. I just get it done. It. So this is a use it one. This is the example one, and use it one, and एग्जाम्पल हो गई यहाँ पे, ये हुक हो गया, ये हो गया 5. Do you need data? Still confused between AI, ML, and real AI. AI. ML. There are 4 other ways AI learns or generates intelligence. AI ways to generate intelligence: machine learning. We covered this. Supervised evolutionary learning, Bayesian learning. Okay, just wait for a minute. There is a call I have. If take. Okay. Okay. Oh. Okay. Got it. Okay, my screen is here. I got it. Okay. ओह माय गॉश, कहाँ जा गया ये? मैं कब से बोले कैमरा पता नहीं कहाँ उड़ गया ये. So matters, here we go again. Entire screen. Let's move on. Okay. So यहाँ पे evolutionary learning, machine learning, Bayesian learning, case based learning, expert system reasoning, not learning, evolutionary learning, a genetic algorithm inspired by Darwin's natural selection, how it learns, create over 100 random solution, test all of them, keep the best one, combine plus mutate them until the great solution found, data needed, it generates and tests its own solutions. Real example, NASA used it to design antenna shapes no human could have thought of, optimizing delivery routes, designing drug molecules, training game, playing AI movement. Okay, how it learned, create 100 solution, test all of them, keep the best one जो survive कर जाएगा. और combine, repeat this thing. Bayesian learning, probabilistic reasoning, inspired by how humans upgrade beliefs. Start with belief. I think 30% chance this email is a spam. New evidence arrive. Email contains word lottery. Update the belief. Now 80% chance this is a spam. More evidence. Belief keeps updating. Yes, but very little works well. Where ML needs thousands of examples to learn. Data needed. Yes, but very little works well. Where ML needs thousands of examples. Data needed, yes, but very little works well. Where ML needs thousands, data needed, yes, very little, but very little works well. Where ML needs thousands of examples. Bayesian, इसमें न्यू एविडेंस आया, फिर अपडेट किया बिलीव का. अच्छा भाई 90% चांस स्पैम का है. Evidence arrive, email contains word lottery. Okay, this thing, medical diagnosis with limited cases, spam filtering, whether probabilistic, and this thing, case based reasoning, learning from past cases, how lawyers and doctors think, how it learns new problem. Okay, I think so. I will let me complete it. This inspired how lawyers and how it learns new problem arrives, search memory for most similar past case, update that solution to correct problem. If it works, stored as new case, memory grows with every solved case. Data needed, yes, but individual cases, not a statistical data set. Each case one complete story. Real example, legal AI finding similar past judgments, medical diagnosis from similar past, customer support finding this, architectural design from past buildings, expert system reasoning, inspired human expert knowledge, how it was, interview a human expert, encode all their knowledge as rules. If symptoms A, symptom B, a disease X, system reasons through the rules to reach conclusion. Data needed, no human knowledge encoded directly. Important, this is not true. This system does not improve over time. It reasons from fixed encoded knowledge. This is the historical bridge between if else and true learning. A real example is 1970s medical diagnosis system, MySyn, early financial advance system, tax filing systems, technical support, and threshold. Okay, got it. So how they all compare method, supervised ML learns, yes, large, data needed, gets better. Unsupervised ML, yes, large, yes, data needed, yes, reinforcement, self-generated, evolutionary, self-generated, yes, Bayesian, small Bayesian क्या था. Bayesian जैसे कि अच्छा यार ये हो सकता है. ओहो अच्छा, अपडेट कर बिलीव का ये इस तरीके से. More evidence believe, yes, but very little works well. Where ML needs thousands of examples to learn. Okay, ML. Okay, case based cases, yes. Expert system, learns no, if else no, expert system, updated framework, ways, which way to learn large data, known answers, large data answer, no data, trial and error, reinforcement learning, no data and evolve solutions, evolution learning, small data, update bleeds, Bayesian learning, in individual past cases, case-based reasoning, human knowledge encoded, expert systems, human knowledge encoded, expert system reasons, does not learn. One analogy: supervise a student with textbooks and answer. A student finds 1% raw notes. A student learns only by taking exams, passes, rewards, fails penalty. Evolutionary: 100 students compete. Best ones teach the next generation. Detective updates suspects list as new clue arrives. Mhm. A lawyer wins cases by finding similar path adjustments. Law book. Okay, yeah. These two are just confusing for me, and but Bayesian and case space, I will try to get it after some time. But here we go. Are you still confused between ML? Yes. So I think so. We done it good. We done it good. So AI. One thing I think I should do, I will try to make a, and this one I think so I should need a picture, but I will try to make it handwritten this time, and let's see if this handwritten works well or not. So I'm going to use my textbook here, and let's see if it's work well or not. So my understanding is this. So this is the AI. And this ML. Okay. This is DL. So I just made this picture here to get this understanding. AI the main box, ML box under AI, and AI box, DL equals to box and ML box. Got it. So I think so. It seems good. Let me take a picture and try to. I don't think so. This is going to be. And I'm going to send the picture here. What about वे यार ये कहाँ गिर रहा है भाई? What about if I post this with this pic. Okay, so yeah, I just signed it from here, and let's see how it's work. Okay, so let me show you the pic. दिस अच्छा, मैंने मोबाइल से इसको सेंड कर दिया है और अभी तक यहाँ पे अपडेट नहीं हुआ है ये डेस्कटॉप पे. What I could do, I could go here again and convert streaming into actionable post. Okay. What? आ क्यों नहीं रहा यार? इसको आ जाना चाहिए. I think so. It should be there. Okay. आ क्यों नहीं रहा ये? So I think so. If I यार यहाँ आ नहीं रहा. मैं इस इमेज को लाऊं तो ज़रा. इस इमेज को लाऊं तो ज़रा. चल भाई. आ जा यार. अबे मैं इसको दोबारा से बंद करके खोल भी रहा हूँ, अगर फिर भी ये नहीं आ रहा. आ गया आ गया आ गया आ गया आ गया. इसने लोड नहीं किया. सिंकिंग जो है ना, आई थिंक सो इस सॉफ्टवेयर की बहुत ज़बरदस्त नहीं है. अब आया ये. देखिए मैंने ये इमेज बनाया है. So I think so this will work fine, but I will make it more a better one. ठीक है. AI equals to the main box. ठीक है. ML equals to box in AI box. DL equals to box in ML box. ठीक है भाई, ये हो गया. अब मैं इसको ये करूँ, इसको थोड़ा सा बड़ा बनाऊँ ताकि समझने में आसानी हो जाए, और इसको यहाँ ले जाऊँ. तस्वीर दिखाऊंगा यार तुम लोगों को. क्या ये? और फिर ये आ गया एक. फिर ये आ जाएगा मेरा दूसरा बॉक्स. ठीक है. फिर मेरे पास ये आ जाएगा तीसरा बॉक्स. ठीक है भाई, अब हो गया. अब मैं इसमें करूँगा AI, डालूँगा इधर. ये इधर आ गई. उसके बाद मैं यहाँ पे डालूँगा ML. दिखाऊंगा कितनी अच्छी ड्राइंग बनाता हूँ मैं. ML. ठीक है. और फिर यहाँ पे डालूँगा मैं DL. What? Okay, got it. So AI AI equals to artificial intelligence. Okay, ML machine learning. Okay, and DL is to deep learning. Okay, so I think so this is a much better pick. I have to take it now here. Okay, man. Okay. Uh, okay, if I give the headline AI, okay. If I give this headline, which I would say this thing is this correct? Let me, because I just have this understanding that this is the correct one. mm, okay, I don't like is the point. A handwritten message was someone generally learning is trust most of the sheer developing design graphic. Correct, but only half truth. Please like Apple, but this one is so I think so this one works well. Let me try it again. Okay, now I'm going to send this pic here. What about this? This. Okay, I just sent it here on Claude. Oh my gosh! Oh my gosh! Okay, let's see how it works. Here's the hook. Hook with explain with the nested box. It is great opening night. It stops the scrolling. It changes the common belief. It creates curiosity. Better than the first and post this कोड ओके मेरे पास यहाँ पे आ गया मुझे नहीं मालूम ये क्यों जो है वो नहीं दिखाता मुझे उसको बंद करके खोलना पड़ता है उसके बाद अभी भी नहीं आया अभी भी सिंक नहीं हुआ इट शुड सिंक टिल नाउ मेरे पास यहाँ पे ये मैंने पोस्ट लगाई है तस्वीर यू कैन सी ये यहाँ पे आ चुका है ठीक है तो मुझे नहीं मालूम ये यहाँ पे काहे को ये देर लगाता है ये भी देखिए खुद आता है तो सही है तो तो यहाँ पे अच्छा इसने मुझे यहाँ पे बोला है कि दिस इज़ दिस सिग्निफिकेंटली बेटर देन द फर्स्ट वन इम्प्रूव फर्स्ट आइकॉन और फिर ये इट्स गुड स्ट्रॉन्ग टाइटल स्ट्रॉन्ग हुक suggest caption to pair with most people use a different like they mean the same thing they do not is the main box. You take the photo with notebook completely flat and natural daylight. The slight angle shadow reduce readability. Okay, okay, I think so. It says that मुझे इसकी तस्वीर बस अच्छी रहनी है और ओवरऑल तो ये बोला है कि इट्स गुड. सो मेरा ही हाथ आ रहा है, मेरे ही हाथ की इमेज है वो असल में. Okay, let me take this pic here. अंधेरा नहीं आना चाहिए ना यार. Okay, now this pic will work. Okay, now yeah, let me make it correct. और इसको मैं reduce कर दूँ. अबे क्या है ये? Okay, अब आ गया ये ऐसे करके यहाँ पे. Come on. Okay. Okay. But I think so. However, let me get. I think so. It is all good. मैंने यार ये अभी भी इमेज इसने नहीं लोड की. रियल टाइम सिंकिंग इसकी नहीं हुई है भाई. मैंने यहाँ पे मेरे मोबाइल में आ रहा है इमेज और यहाँ पे नहीं आ रहा. Let's try again if it's all working or not. Well, okay, so अच्छा इमेज तो नहीं आ रहा वो जो मैंने भेजा है, बट ये है कि वो इसी तरीके का ही इमेज था मगर वो इम्प्रूव वर्जन था. ओके, लेट मी सी एंड डू पोस्ट ऑफ इट. और मैं इसको बोलता हूँ एनालॉजी को बोलता हूँ एग्जाम्पल. ओके, in real life question. So yeah, let's see how it all goes and I will try to make it. I think so it is fine as well. Okay, so yeah, let's see what is happening and we will try to. Yep, it is good learning today and I will pause this now. So we will explore other content creation of the topics we just made in upcoming series as well. Bye.